In this section, we will look at how to divide polynomials. Let's begin by looking at how to divide a monomial by a monomial. This can be done by using the method of simplifying fractions and the quotient rule for exponents in order to get the expression to its simplest form. And by simplest form, we mean that the numerator and the denominator have no common factors other than 1. So, in this example, let's begin by looking at the coefficients. And notice that we are looking for common factors between the coefficients, so we have 24 and 6. We know that we can split 24 into 4 times 6, giving us a common factor of 6 in the numerator and the denominator. So we can divide through by that 6, leaving us with 4 times 1 in the numerator. Then let's look at the variables in both the numerator and the denominator. And notice on the numerator we have x to the 6th, so we know we need to multiply 6 x's in the numerator, and in the denominator we multiply x by itself 4 times. And when we do this, we end up with common factors of x in both the numerator and the denominator, leaving us with 1s in those places. And as a result, we have 2 x's left in the numerator. And so, if we take a look, all that we have left other than multiplication by 1 is a 4 and x to the 2nd in the numerator. So our answer would be 4x squared. Now, if we did this exact same problem using the quotient rule for exponents, we would also start with the coefficients and look at 24 divided by 6, which would give us 4. And then using that quotient rule, we know that we'd have to take the exponent from the denominator and subtract it from the exponent in the numerator. So we would have 6 minus 4, and the result would be 4x squared. Now let's look at how to divide a polynomial by a monomial. Notice that the polynomial is being divided by a common denominator. Therefore, you can take each term in the polynomial and divide it by that common denominator. So that would give us, in this case, 2 separate terms. However, you want to make sure that the operation that is being used in the polynomial is also being used as you split it into separate fractions. And keep in mind that the monomial, or c in this case, cannot equal 0. So when we look at an actual example, we have a polynomial in the numerator and a monomial in the denominator. Therefore, that common denominator of 4x can divide both the 12x squared and the 8x. So our first fraction that we're breaking this up into is the 12x squared plus 4x. Now, remember, we want to keep the same operation when we split this into different fractions. So we have an addition sign here, and we know that the next fraction we're breaking this into is that second term of 8x divided by the same denominator of 4x. So we get 8x divided by 4x. Now if we go through and simplify what we just came up with, we have 12x squared divided by 4x. So start with the coefficients. 12 divided by 4 gives us this 3. And then using the quotient rule of exponents, we want to subtract the exponent in the denominator, which is the 1, from the exponent in the numerator, which is the 2. So we get x to the 2 minus 1 power. And then we're moving on to the second term. Again, looking at the coefficients, we have 8 divided by 4, which is 2. And like bases of x in both the numerator and denominator, each of those x's is raised to the first power, so x to the 1 minus 1. Now, when we simplify this even further, we see that we are left with x to the 2 minus 1, or just x to the first power, plus a 2, because this x to the 1 minus 1 power gives us x to the 0, and if you remember the 0 product of exponents, x to the 0 is 1, so it would be 2 times 1, or just the 2.